Imagine waking up tomorrow and discovering that the biggest problem facing artificial intelligence has nothing to do with intelligence. Not chips, not data, not even money. Electricity. Because behind every AI model you use, there are machines running inside enormous data centers, machines that can consume as much power as entire neighborhoods. And now, as AI becomes smarter, companies like OpenAI, Google, Microsoft, and Nvidia are building them at a scale the electrical grid was never designed for. Here's the strange part. AI is becoming more efficient. Every year, the machines can do more work with less energy. So why are the world's biggest technology companies racing to secure more electricity than ever before? Because the next battle for AI may not be fought inside a computer. It may be fought over power plants, transmission lines, and who gets the electricity to run them. And if that happens, the future of artificial intelligence may depend on something surprisingly old-fashioned. Power. We rarely think about electricity when we use AI. We type a question, an answer appears. We generate an image, summarize a document, create a video, and it feels almost weightless. But behind that simple interaction is a physical machine. Thousands of powerful processors working together inside massive data centers. And these machines don't just need electricity to think. They need electricity to stay cool, to move data, to store information, and to keep running around the clock. This is where the story gets surprising. Because the amount of electricity used by each individual AI task can be getting smaller as the technology becomes more efficient. But at the same time, we're asking AI to do far more. We're giving it longer reasoning tasks. We're generating images and video. We're building AI agents that can perform entire chains of actions. And billions of people are beginning to use these systems. So the machines become more efficient, while the world asks them to do more. And that creates a problem hidden behind the AI revolution. Demand is growing faster than efficiency can erase it. Data centers are now becoming some of the most energy-intensive buildings on Earth. And as AI servers become more powerful, the electricity required to operate them is rising with them. The result is a race that most people never see. Because the next generation of AI won't only need better chips. It will need more buildings, more cooling, more transmission lines, and enormous amounts of reliable electricity. And that raises the question at the heart of this story. If intelligence is becoming digital, why is its future becoming so dependent on something as physical as power? To understand that, we have to go inside the machine itself. For decades, computers followed a simple rule. More computing power meant more hardware. But artificial intelligence changed what that hardware had to do. Traditional processors were designed to handle instructions one after another, with flexibility being the priority. AI needed something different. It needed to perform enormous numbers of mathematical calculations simultaneously. That is where GPUs became so important. Originally built to render graphics, GPUs turned out to be remarkably good at the mathematics behind neural networks. Instead of asking one processor to handle a massive calculation alone, thousands of smaller processing units could work on different pieces of the problem at the same time. And suddenly, training an AI model became a completely different kind of computing problem. But there was a catch. Packing more computing power into the same physical space also meant packing more heat into that space. The old idea of simply adding more servers was no longer enough. Engineers had to rethink the entire data center. Power delivery had to become more sophisticated. Cooling systems had to evolve. And server racks began demanding levels of electrical power that traditional facilities were never designed to handle. This is the hidden transformation behind modern AI. The machine isn't just getting bigger. It's getting denser. More processors, more calculations, more heat, more power concentrated into less physical space. And that density is changing the economics of the entire data center industry. Because when one rack can consume as much electricity as dozens of homes, adding another rack isn't simply a technology decision anymore. It's an infrastructure decision. And then something even bigger happened. AI stopped being used only for training. It began answering questions, generating images, writing code, analyzing documents, and eventually performing increasingly complex tasks for millions of people simultaneously. The machines that once trained the models were now being asked to serve them. And that's when the demand curve began to change. Because the AI revolution wasn't going to be powered by a handful of giant computers. It was going to require an entire new generation of computing infrastructure. And the companies building that infrastructure soon discovered a problem they couldn't solve with a better chip. They needed somewhere to put all that power. The real turning point came when AI stopped being a research experiment and became a global product. Suddenly, the demand wasn't coming from a few laboratories. It was coming from millions of people. Every search, every generated image, every piece of code, every AI assistant, and increasingly every automated task adds another workload to the infrastructure behind these systems. And unlike a normal software application, AI has a physical bottleneck. It needs computing capacity. That means companies can't simply update an app and instantly double its capabilities. They have to build more servers, more facilities, more capacity, and those facilities are becoming enormous. The International Energy Agency estimates that global data center electricity consumption reached roughly 415 terawatt-hours in 2024. By 2030, its base case projects that figure could approach 945 terawatt-hours. That's roughly the electricity consumption of an entire major country being added to the global system in just a few years. But here's where the competition gets interesting. The biggest technology companies are no longer competing only for the best AI models. They're competing for the physical infrastructure needed to run them. And electricity has become one of the most difficult resources to secure. A company can order more chips. It can build another data center. But if the local grid doesn't have enough generation capacity or enough transmission infrastructure to deliver that power, the project can simply wait. And waiting is expensive, because AI companies are racing against each other. Every month of delay can mean falling behind competitors who are already deploying newer models and larger computing systems. So the question has changed. It is no longer simply, who has the smartest AI? It's becoming, who can build enough infrastructure to run it? That shift is turning electricity into a strategic advantage. Locations with abundant power suddenly become more valuable. Long-term energy contracts become more important. And access to the electrical grid can become just as critical as access to advanced chips. But there is a problem hiding underneath this race. The world's power system wasn't built around the idea that thousands of megawatts of new demand could appear in concentrated areas almost overnight. Power plants take years to plan and construct. Transmission lines can take even longer. And the grid has to balance supply and demand every second. So while AI companies are moving at the speed of software, the electricity system moves at the speed of infrastructure. And that mismatch may become one of the biggest obstacles standing between today's AI ambitions and tomorrow's reality.